Hello everyone, welcome to this seventh lecture in this course that is Introduction to Remote Sensing, and in this particular topic we will be discussing image interpretation and what are the principles of image interpretation. So far what we have seen that there are different channels are there, different satellites are there, we acquire the data, ultimately the images are generated by the satellites, and once the images are with us, then the application part or interpretation part will start. How to use those images, that is a very important thing. So in this we will be discussing about principles of image interpretation, especially visual one, and then of course digital nowadays are also possible to some extent. So in most of the cases visual interpretation of satellite images is important, especially in remote sensing applications, as well as nowadays we use in GIS remote sensing images extensively, and therefore when before they go into the GIS database, we make certain interpretations, make certain maps or classify these images for different types of applications in GIS. Visual interpretation starts basically visual interpretation will come once we understand how images are acquired, how different objects on the surface of the earth behaves in different part of EM spectrum, and once we have, as we have discussed in previous lectures, that once we have understood all those spectral curves, behavior of different objects in different part of EM spectrum, absorption, scattering and other phenomena, then interpretation of such images, visual interpretation of such images becomes much easy and reliable. So this is basically a skill. Visual interpretation is the skill that an image interpreter apply equally to an image. And as you know that once the data has been acquired, and then this is RS for the remote sensing data products, we may go for photographic products, or nowadays we use screens and directly we display images, make the interpretation on the screens, make a output map and so on. So that is also possible. So maybe in the paper form or maybe in the digital form. And this false color composite I will come little later. So we may make colored images, we make black and white images depending on our applications. Once the data is acquired, then certain corrections are done by the organization which acquire the data, especially the radiometric corrections. But some corrections one has to perform on the raw data, and that is like geometric correction, atmospheric corrections on the data, and finally then georeferencing or geometric corrections are also done so that we can then directly use onto the GIS platform. Now about the false color composite, this is very important, and this is a very standard practice of creating colored images of satellite data. So what we will see that like in different part of visible spectrum, the green and red channels are blue is not involved here. So green channel is assigned blue color in a standard false color composite, red channel is assigned the green color, and now near infrared channel is assigned red color. And because of this everything is becoming false, like green channel is assigned blue color, red channel is assigned green color, near infrared is assigned red color, and therefore the color composite which is created through this additive color scheme, this kind of color composites or color images can be created using satellite images. But because we are not putting the corresponding color, like green we are putting blue, for red we are putting green, and for infrared we are putting red, and therefore we call as false color composites. This became essential because we know by spectral curves that the vegetation reflects maximum in the infrared or near infrared part of EM spectrum. and we want that vegetation should be discriminated very easily with the vegetation or bare soil or rocks or any other objects which are present on the surface of the earth, and therefore that channel has to be involved. So now which color one will assign? So in a standard false color composite, generally the red color is assigned for this infrared channel, and then remaining two colors are assigned for remaining two channels, and therefore that makes. Now as you can see in false color composite, in a standard false color composite, vegetation will always appear red. More healthy vegetation, more dense vegetation, you will see will have more red color, and whereas your water bodies or bare soils will have different colors in a standard false color composite. This is very standard practice of creating false color composite. It's especially when we had limited number of bands, but after having more bands of EM and part of EM spectrum like in Landsat EM or ETM plus, it is possible to create near true color images as well. But in case of Landsat MSS, we had only 4 channels, and therefore this was a very standard practice which is still being followed. The main purpose here to put bands in such a in color combination that different objects can be discriminated very easily. That is the main purpose. That is why such schemes have been developed. One example of Delhi area is shown here, and that what we are seeing here is a image of Delhi area with it's a panchromatic from our own Indian remote sensing satellite which was acquired in 1997. Almost of the same year, not in just a few months before, in 1996, LIS-3 image of the same area was also acquired. Now we can use these images and these color combinations to create some new products which are which will show the vegetation, water bodies and built up areas very easily, very distinctly, and this the purpose of creating such color composites. Here one more extra thing has been done using this image fusion technique. The high spatial resolution data which was available from PAN image has been merged with relatively low spatial resolution of LIS-3, that is 23.5 meter, and using the same color combinations, and a new product at high resolution has been created, and which is false color. So, but our interpretation becomes much more easier and reliable. That is why such approaches are followed. So, false color composites, creating them, interpreting is very important in remote sensing. Now, visual interpretation, basically the process of identifying what we see on the images and communicate the information obtained from these images to other for evaluating its significance. Manually earlier we used to put a transparent sheet and demarcate different areas, but nowadays on digital images one can assign different colors and can create output maps. For example, using a false color composite image, we can create a land use map, land cover map, forest density map, maybe a lithological map, and so on and so forth. So, such images can be used, their color combinations can be used to create new outputs for different applications. And this also includes the relative locations and extent of the area and use of such products, satellite products of either single band. I have shown the example of Delhi area, that is this panchromatic, or you can involve multiple bands and then show this single band, false color composite, true color composite, extract the information which is present for subsequent input to the GIS. The main purpose of creating these color composites and other things is to discriminate between different objects. Even if throughout in an area where vegetation is there, one would in certain application one would like to see the differentiation within the vegetation. Might be differentiation due to species, might be the health of vegetation. So that is why such image interpretations are required. There are certain keys, certain standards which are followed while making image interpretation, especially the visual interpretation, or we say criteria for identification of an object with interpretation or key elements, interpretation keys we call them. These are basically first the location, whether it is we are on the land or in the sea or in a water body or in a hilly mountain. So the location is very important. Then the size of an object, that help us to make interpretation about the about an object which is present. Then the shape of the object, like for built up areas generally you will find them either they are square or rectangular. You may not find many built up areas which are circular or having some other shapes. So that is why it becomes easier of understanding objects which are present on the earth and with their shape. Shadow also gives us a lot of information about an object, especially in the hilly terrain. It gives you the feeling about the depth or depth perception, whether it's a valley or a ridge or whatever, or in plain areas you may not have shadows, but if there are some objects which are present which will have shadows, like tall building will always have shadow in daytime images. Tone and color plays very important role, and then texture is also there, whether it is fine texture or coarse texture, depending on the type of objects which is present. Within a forest area you may find certain vegetations, certain areas which are showing fine texture, and in the same forest area you may find showing coarse texture. Pattern also, pattern makes a lot of help in while making the image interpretation. Height and depth is connected with the also shadow, and then where it is located, though is a site, location and association, like beach generally are associated either with the sea or large lakes. So there is that kind of association is mentioned here. Where it is things are situated, because in normally in a large land area you may not find beach and other things are. Same might be with the sand dunes, deserts and other things and their association. So that is very important while making interpretations, whether in reality these things can be found at that location or not, that has to be understood. That is why site situation and association is also very important key, one of the keys of image interpretations. So we will go one by one. First, location. There are two primary methods to obtain precise location in the form of coordinates. One is the using the survey in the field using traditional survey techniques, or nowadays some navigation systems like GPS instruments, or collect remote sensing data of the object, rectify the image. Rectify means here making geometrically corrected or doing the georeferencing, and then extract the desired coordinate information. So location is very much required for as one of the keys of image interpretation. Most of the users or scientists use relatively inexpensive GPS instrument in field to obtain desired location of an object. When we go for some mapping, maybe geological mapping or some mineral exploration, maybe for water or for some civil engineering purposes, we might carry our GPS and can get the location of that particular object, and that makes a very useful input for image interpretation. Then next is the size. The size of an object is one of the most distinguished characteristics and one of the more important elements of interpretation. Now this size has to be understood because depends, it will influence as per the spatial resolution of your satellite image. If a object which is very small and you are having a satellite image which are having coarser spatial resolution like NOAA HRR, which is having say 1 kilometer spatial resolution, then these objects will not be visible at all. Whereas you go for a very high spatial resolution which is having say 2 meter or 30 centimeter spatial resolution, then all these details of these objects are present. So size is really depending on the spatial resolution and object, of course object itself. So most commonly the length, width and perimeters are measured. To be able to do this successfully, it is necessary to know the scale of the photograph. If you are using a printouts of a satellite image or a spatial resolution in case of a digital image, and measuring the size of an unknown object, and that will allow us to make correct interpretations and may provide possible alternatives as well. And most commonly measured parameters as mentioned, length, width and perimeter area, and maybe occasionally maybe for related with water or other things, maybe the volume of the water. The third one in this series of keys of image interpretation is the shape. That is, the shape of an object is described as geometric form represented on an image. Again, shape may remain little different depending on again spatial resolution. So one has to be before making interpretation, one must know what is the spatial resolution of that image on which interpretation is being made, especially on the digital images. Regular shapes are signs of man-made objects like buildings, maybe roads, maybe some track and other things, whereas irregular shapes with no distinct geometrical pattern are signs of a natural environment like a water body, shape of a water body, maybe a fluvial system like a river or a mountain and so on and so forth. Now shadow, this is the fourth keys of image interpretation, the shadow, and generally remote sensing data from polar orbiting satellites or sun synchronous satellites are collected between 9:30 to 10:30 in morning hours. That is why they are called sun synchronous. And to avoid this basically it is not too early in the morning, not too late in the afternoon, and to avoid the extended shadows in the images. That is how these are designed. But shadow can obscure other objects that could otherwise be identified. So especially in the hilly terrain like Himalaya, where you are having high ruggedness, so there is a mountain peak and suddenly there is a valley, and then in your satellite images you would find large shadows, and these shadows will may give you wrong interpretations. So one has to be very careful. So the shadow cast by an object may be the key to the identifying by the another object. So the shadow generally helps, but sometimes it can also create problems. Examples are here. This is Washington Monument, which is very high, as you can see through a photograph taken from the ground, but the same Washington Monument is not looking as tall from top or from a satellite image, but if you see the shadow. So this is taken in the morning hour, that means the sun was in the southeast quadrant and therefore shadow is in the northwest, and even the measuring the length of shadow and the elevation angle of your sun, one can estimate the height of this tower as well based on the satellite images. So this kind of applications of shadow are possible. Take example, as I have already mentioned about the Washington Monument. While viewing this from above, it can be difficult to discern the shape of the monument, but the shadow cast, this process becomes much easier, and it is good practice to orient for photos or satellite images in that way that the shadows are falling towards the interpreter, and a pseudoscopic illusion can be produced if the shadow is oriented away from the observer, and this happens with the low point appear high and high appear low. So what does it mean basically here? That generally the data is acquired between 9:30 to 10:30, but our brain has thinks that illumination is coming from opposite direction, and therefore if we keep like this, then there might be wrong interpretation. So one has to be very careful while using shadow to interpret certain objects which are present on the earth. As I have mentioned, the shadow gives the height information about hills, towers, tall buildings, etc., and if we know the altitude of the satellite and the angle, then probably the shadow can give you the estimations of the height as demonstrated here. One example of that point which was just mentioned is that when satellite images are acquired by this polar orbiting satellite, sun synchronous satellites, at that time sun is in the southeast quadrant, and therefore if I say this is the snow covered mountain peak, but you might see that it is showing in a form of depression, because what happens when the sun is here, the satellite has taken the image from the top, the shadow will be in the opposite direction of the interpreter, and if this situation comes, then we will see a inverted phenomena or a false topographic phenomena. But if I rotate this image by 180 degree like this, then we see incorrect perception. That means the illumination source in this first image, on the left image, was in the southeast quadrant, has been pushed back in the northwest quadrant in the right image, and therefore the shadows are towards the interpreter, and once this situation comes, then you see topography in correct perception. So we call as a false topographic perception phenomena of hilly terrain. It is present in all satellite images, all parts of the earth, even on moon surface, even on Mars. So while using shadow during interpretation, one has to be very careful that in which direction shadow is falling, and keep in the direction or keep in the same hemisphere where the interpreter is present, and if that means you keep the illumination source in the northwest quadrant rather than in the southeast quadrant, as really happens in case of this sun synchronous satellite images. So one has to be very careful while using shadows in the interpretations, and especially in the hilly terrain where shadows are very common and which give you the depth perception as well. And another few more keys of image interpretation, important one, the tone and color. The different parts of EM spectrum are used to create for different bands, and they record the remote sensing system displayed in shades of grey ranging from black to white. So when only the colors, when you combine 3 channels, use the additive color scheme, then you create the color images. Otherwise what you will see in the grey shades, and there the tone will play important role. So continuous grey scale varying from white to black refers to the relatively brightness or color of the object. Like for example, in the visible channels the vegetation may appear very dark, whereas in infrared channels vegetation will appear very bright, and different objects like water and bare soils will behave differently in different part of EM spectrum, and therefore an interpreter should have the knowledge of that which band he is interpreting, which band of remote sensing data he is interpreting, and accordingly the tone he might expect. And colors are when you combined 3 channels and make color composites, and these signatures of tone and color can help to understand why certain objects appears as they do in black and white or color images, and these shades of grey are referred as tone. Darker of an object appears, that means it is reflecting less in that particular channel. Color images often preferred because as opposed to the shades of grey, and the human can differentiate maximum 40 to 50 individual shades of grey, whereas in case of colors we can detect thousands of colors. So that is why colored images are most liked and used in image interpretations. Color aids in process of photo interpretations. It helps us and make this photo interpretation much easier as compared to grey images. That is why we always create color composite, that even might be a false color composite, but it is great help while making interpretations. Texture Another important characteristics or another important key of image interpretation, that the characteristics, placement and arrangement of repetition of tone or color in image, and a visual impression of roughness or a smoothness of image in a particular region. Another key is the pattern in the spatial arrangements of the objects in the landscape. The objects may be arranged randomly or systematically. Generally natural objects are not arranged systematically, and whereas man-made might be arranged systematically, and they can be natural with a drainage pattern of a river or man-made. Typical objectives used in describing pattern are like random, systematic, circular, oval, linear, rectangular, curvilinear. Mainly we use for different types of lines, especially like drainage lines, maybe some other networks, for example road and others. Now where such objects are located, that is the site, situation or association, that will also decide what kind of object it is, and it will help in the image interpretation. So site has unique physical characteristics which might include elevation, slope, type of surface cover, etc. For example, grass, forest, water, bare soil and other things. A site can also have socio-economic characteristics such as value of land or closeness to the water, closeness to maybe road and so on and so forth. Situation refers to how the objects in an image are organized and situated in respect to each other. So their association is very important. I gave the example of like beach are associated generally along the sea or along the large lakes. So the most power like man-made structures, most power plants have materials and building associated in a fairly predictable manner, and this is how you make interpretation that this might be a power plant, might be a cement factory, because if it is power plant it will have some say thermal power plant, it will have some coal dump, it will have some fly ash dump, it might have storage for water, and then power lines might be coming out of that, a powerhouse might be there. So all these association of different objects will make your interpretation easy, and you would be able to identify that probably this is a thermal power plant. So association refers to the fact when you find a certain activity within a photo or an image and you usually encounter related to associated feature or activities. Site situation associations are rarely used independent of each other when analyzing an image. There can be like a railway station. So if it is a railway station, you will find a track, you might find a platform, a shadow, and there might be more number of lines in a few kilometers within the range of a railway station, and then maybe less. So based on these associations you can interpret very easily about a particular object which might be present on your image. So an example is this would be large shopping mall. Usually there are multiple large buildings, massive parking lots, and usually located near a major road intersections. So association is another very important key of image interpretations. Here like I am showing that there are water bodies and there is association of vegetation along with the water bodies in the downstream area. So that clearly tells that probably these are the agricultural lands and which are getting feeding or getting water from these small reservoirs, and whereas you do not have much water bodies here or reservoirs, and therefore you do not have much growth of vegetation or agricultural land. So this association is making this kind of image interpretation in a much easier manner. Similarly, one more example I am showing from Bundelkhand region where there are a lot of quartz reefs are there. So while studying such images or making interpretation of images, we can even identify a location for a future dam, because we know that there are quartz reefs, natural kind of dam is there, and there is no blocking of a drainage line or riverlet which is going through these quartz reefs. So if it is blocked, then it can become a reservoir. While learning from here or making interpretation in this image, probably in the same, almost in the same area or nearby areas, we can do some futuristic work as well using this concept of association or image interpretation, overall image interpretation. So that is the advantage of making good interpretation of satellite images. So this is the quartz reef. If a stream is going, if it is blocked, then a dam can be constructed, and this simulation of dam has been done in GIS platform. It shows that how much area, if this much height of dam is created, how much area will be inundated, and so on, which land use will submerge, that can also be estimated. So that kind of work can be done starting from satellite image interpretations. So thank you very much.